To learn more about earning college credits with study hall courses, visit gostudyhall.com or click the link in the description. We've all heard people blame the algorithm for why they're shadow banned and their hour-long Get Ready With Me that is half out of focus only got 32 views and 3 likes. And while there is an algorithm behind YouTube and TikTok, it might not work the way you think it does. As programmers, we make decisions about how our computers make decisions, so any assumptions or mistakes that we make can get amplified in our code, including software that we use to make big engineering, governmental, or medical decisions. So, even the notorious algorithms that shape our YouTube and TikTok feeds are ultimately designed, programmed, and reviewed by people. And with great computing power comes great responsibility to understand how computer programs impact all of the people who use them. I'm Sabrina Cruz, and this is Study Hall, Code and Programming for Beginners. An algorithm is a set of step-by-step instructions that can be followed to solve a problem, whether that's finding the average of a set of numbers or recommending another YouTube video for you to watch after this one. Might I suggest the one where I memorized 3,141 digits of pi? That's not clickbait. I did it. Now, you might be thinking, Sabrina, this sounds like literally every computer program we've talked about in this series. And that's true. Whenever we code something, we're giving instructions that a computer can follow to solve a problem. Computer programs are one of the most common ways that we can implement algorithms, but an algorithm is a more general concept than that. An algorithm can be written in plain English, pseudocode, or even flowcharts so that the instructions can be shared between programmers and implemented in whatever programming language you want. And unlike building IKEA furniture, we don't need to exactly follow the logical instructions. We can mix and match one or multiple algorithms however we want. They're kind of like templates or outlines that we can customize. For example, we can reuse the same common algorithm in lots of different programs, or pick a specifically helpful one that's tailored to a problem that we're solving. We can also repeat an algorithm many times within a program to accomplish different tasks, or combine multiple algorithms together. And even though algorithms are associated with tech, AI, and social media, they aren't just for computers. A lasagna recipe is an algorithm. It's a set of instructions that solves the problem of the lack of delicious pasta layers in my life. And it is a problem. The input of a lasagna recipe is what ingredients to use, and the algorithm is the step-by-step instructions telling a human how to combine those ingredients and how long to cook them. Finally, the output is a delicious tray of food. A lasagna algorithm shows us the key steps from input to output, but you can make personal choices to riff on that logic, like changing the size, the type of sauce, or whether or not you add 2 or 3 types of cheese to the top. This flexibility you have in cooking applies to writing computer programs too. For instance, you can base your code on an algorithm that recommends videos to users, but you can choose the programming language, make adjustments for the amount of data you're working with, or decide that you want more people to see videos tagged with #goblins, just for the heck of it. All these choices that we make when implementing an algorithm have real consequences. Like if we wanted a non-lasagna example, check out the world of medicine. In 2019, the journal Science published a study revealing many algorithms doctors and hospitals use to decide who needs care contain a racist bias. In order for the algorithm to decide that they needed the same treatment, Black patients had to be a lot sicker than white patients. And this happened because of the data the creators of the algorithm chose to use. The algorithm was trained on past data on healthcare spending, without accounting for the fact that Black patients have a history of having less to spend on healthcare compared to white patients because of long-standing wealth disparities. So even if a decision feels small or insignificant, it can make all the difference in what users experience, whether they're scrolling through pictures, applying for a job, or receiving medical care. Even our decisions at this point in our programming journey can make a huge impact on users. Let's take a couple of simple algorithms that solve problems involving a list of names, like, say, a bunch of students who are taking an Intro to Programming class. I know, we're really stretching our imaginations here. We want these algorithms to be implemented in any programming language, so we'll write them in pseudocode rather rather than using specific Java syntax. One thing we might want to know is whether a specific student is enrolled in the class, so we can develop an algorithm to determine whether or not a particular name shows up in our list. In this case, our inputs are the list of student names and the specific name that we're looking for, and our algorithm searches for that specific name by looping through the list and using a Boolean variable that is either true or false to keep going or break the loop. Our output is the value of the Boolean when the loop finishes. Another thing we might want to do is count how many times a name shows up on a list, like for an icebreaker on the first day of class. Who wouldn't want to know that there are like 4 different Hannahs in the room? That's fun, right? I mean, 2 out of the 3 people in this room right now are named Sabrina. I call that identity theft. To create this algorithm, we'll also input the list of names and the name we're looking for, but instead of having a Boolean, we can create a variable to help us count, and our output is the value of the count variable after our code is done running. These examples may sound straightforward, but to actually implement these algorithms, we have to make choices about how we're collecting and formatting names. And with each of those choices, we have plenty of room to introduce human biases. Because we're all biased, we all have opinions, preferences, and backgrounds. But it's when we're not aware of our biases that we can cause trouble. Suppose our list of enrolled students has the format last name, first name, which seems simple enough. Mine would be Cruz, Sabrina. And let's say we implemented that first algorithm to look through our list for a specific student who emailed us, Ada Lovelace. But here's the thing, even though she signed her email with that first and last name, her name in the official school registrar is Augusta Ada King, Countess of Lovelace. If the only blank she had to fill in were first name and last name while registering for classes, she could have struggled to enter her name into the system. Maybe she included one or more of her middle names with her first name, or she couldn't fit her whole title because the blank had a character limit. If there's not an exact match between her email signature and her name in our list of students, our program might say that she's not enrolled. Our attempt to implement this algorithm would fail. It's not Ada's fault as a user. It's because our biases about what names could look like were enshrined in the program, so the computer became biased too. This is a pretty low stakes example, but like I said before, the world has plenty of much higher stakes examples. In fact, we talk about this a lot more in our study hall data literacy course. People make mistakes all the time in programming, from errors that need debugging to incomplete data sets. So it's our responsibility as programmers to test our programs, evaluate each other's work, and develop or implement algorithms that serve our users well. If we don't, systems can break, endanger human lives, or be straight up unethical. In 1998, for example, after years of hard work and millions of dollars, NASA launched the Mars Climate Orbiter. Their goal was to collect data about the past climate on Mars and help relay communications to Earth from the Mars Polar Lander and future Mars missions. All the navigation math checked out, but the commands coming from Earth were given in English units, and the program's calculations were set up using metric units. It was a simple human error with huge consequences. The spacecraft, the result of decades of work engineers and scientists put into the mission, veered off course and was lost forever, destroyed in Mars's atmosphere. Even with thorough testing, mistakes happen, and that matters because computers do whatever we tell them to, so computers will also make mistakes, and many people have learned that and continue to learn that the hard way. Not to mention, the kinds of errors or biases we see in computer programs keep evolving. Many algorithms that we interact with nowadays, from YouTube recommendations to AI portrait generators, are implemented using machine learning. Instead of a human coding every line and teaching a computer how to make decisions, we provide lots of examples of what we want the computer to do so it can discover patterns for itself. Now, this isn't the computer thinking for itself, but more like a less explicit way of a programmer giving instructions. If we give these machine learning programs biased datasets to learn from, whether the data is what a motorcycle looks like or what professional writing sounds like, they're going to spit out biased decisions. And every dataset is biased because it's coming from biased people who designed the studies, collected the data, and have subjective worldviews and experiences. Science is not objective. In 2020, for example, an interdisciplinary team at Stanford University published a study about racial bias in automated speech recognition used by programs like Siri or Alexa or those chatbots that are always like, please state your question so we can direct your call. These researchers made 5 speech recognition systems transcribe audio clips from white speakers and black speakers, the latter of which was more likely to use African American vernacular English. They found that there were about twice as many errors for black speakers. On average, 35% of their words were transcribed incorrectly, compared to 19% for white speakers. These speech recognition programs use machine learning, and if the audio samples the programmers use to train the programs aren't fully representative of things like accents and dialects, a whole lot of people lose out on being understood. These 2 examples are just the tip of the iceberg, and a lot of researchers are dedicated to understanding and trying to fix algorithmic biases. But science and tech in particular have a huge and well-documented diversity problem, which for sure contributes to prejudice and the continued use of the imperial system in our programs. Kilometers forever, baby! So, if we're going to program for people and for social good, we need to consider how people are treated at each step, like what data we're using and how we got it, but also whether we should make the algorithm or program or tool in the first place. And we should value and use knowledge from humanities as much as we do the STEM fields. Algorithms drive our modern world, from content recommendations to self-driving cars and everything in between. They can do so much good in the right hands, or they can be implemented messily and create more problems than they solve. This episode isn't meant to scare anyone away from programming. In fact, learning how algorithms work can empower you to understand what choices are being made when we implement them. In a world where code impacts real people every day, sometimes in ways we don't fully see or understand, that's a superpower in itself. Every programmer has the responsibility to speak up, make educated choices, and understand what the technology they're working on will be used for. And if you take just one thing away from this episode, it's that computers don't hold objective truths. They're just as flawed as the humans who build and program them. Like me, you're gonna trust a program written by me? If you're enjoying Study Hall Code and Programming for Beginners and are interested in taking an online course and earning college credit, check out GoStudyHall.com or click on the button to learn more. Thanks for watching, and see you next time.